Okay, hi everyone. Today I just want to make a quick log. Okay, well, first, I recently hit 100 subscribers, so, it might not be much, but still kind of feels like a good milestone, so, thanks to all my subscribers for that. Okay, so today I just wanted to show you guys something cool and also hopefully teach you something. So, one basic thing that a lot of people go through in Unity is making their first controllable character. And I think the easiest way to start with this is by making a sphere controlled character. So this is very simple to do. And first, I guess what I'll do is I'll show you the game, and then I'll go over some of the controls that make this possible, and we'll go through it line by line, and I'll show you how it's all done. So basically, all the features we want to have, all the features that I'm going to show you today are going to allow you to move forward, right, left, back, rotate the camera, and jump. And this is actually a bit of a more sophisticated jump that has a cooldown. Okay, so as you can see, I move using WASD. Using E, I can rotate the camera this way, and using Q, it'll rotate it this way. Okay. As for how the level is constructed, this was all done within Unity with no outside 3D modeling software used. So, I think all of it is pretty self-explanatory though. Most of it is just cubes and cylinders. Okay, so let me actually explain how this works. So most of the code is really contained inside of this script, this control script. So let's go into it. So first I'll cover the basic movement. Okay, so as you can see in the update loop, to read any key inputs, you can simply use if input.getKey, key code, and this can be whatever key you want to assign to that movement. So in this case, I have a rigid body. This is not meant to be like a complete beginner guide, so I will be kind of skipping over. So I won't be explaining everything just so I can save some time. So the rigid body is referenced over in the start function. So my body is equal to this transfer.get component rigid body. As you might know, rigid body lets you apply physic forces to the game object that the script is attached to. So if I'm pressing W, I add a force. And here, what I do is I take the main camera and I use its local forward vector to move forward. And you might be wondering, oh, why don't you just use a world space vector? And the reason I don't do it is because when you rotate the camera, the world space vectors no longer really work, because instead, if you rotate it 90 degrees and you press W, if you use world space, you'll seemingly move to the right. Whereas if I use the camera's local vector space, then if I press W, even if the camera is rotated, I'll always move in the same direction. And you see that for all of these others. So A is left on the WASD configuration. So I do negative main camera dot transform dot right. So I take the opposite of its local right vector. And same thing for this other stuff. Okay, so another basic thing is how do I make sure that the camera is consistently following my sphere? So I initialize an initial offset. Sorry, I'm using initialize a lot. So I take the initial offset, and what I do is I just take the vector from the camera to this, which is the sphere, and I set that equal to offset. So this offset is always the vector pointing from my sphere to the camera, or vice versa, whatever. And then in the update loop, I'm constantly adding the offset to the sphere's current position. So every frame, the main camera's position is being updated to be consistently a set distance away from the sphere. So that's kind of how it works. You do need to know a little bit of, vector math to really get this at a deeper level. But I guess I'll show it real quick. So, offset. So we have a sphere. Boom. Camera. So this is where I initially set my camera in scene mode. So let's pretend that right here is the world origin, otherwise known as 000 on your scene. So main camera dot transform dot position is this vector. This dot transform dot position is this vector. Offset is main camera, so this vector minus this vector. And so really when we subtract something, it's the same as taking the opposite. It's subtracting something is like subtracting the positive component of it, so we just flip it. So really we can take this vector here and we can treat it like this. So this vector is the negative part of this vector, so we flip it. And then when we add these vectors, like this, by putting it tip to tail, the resultant vector is this. And I'll just draw it here too. Oh, I already did. This is the offset vector. We'll just call it off. Apologize for the handwriting. So this is the offset vector. And this is the result of subtracting the camera vector from the the sphere's vector. So we constantly keep the camera at this offset from the ball. And because in this line of code, no matter where the position moves, we're still adding the same offset. So this way you don't see the camera float off into the distance or something. I apologize if that was a bit confusing. I just wanted to explain kind of the math behind it. Okay, so we're already done most of the code. Let's just go over a couple more. For jumping, we check to see if space is being held down, and we also check this jump available boolean. So whenever we press it, again we're using get key down here, so it only checks for the keystroke once. We add a force of positive 300 in the y-axis. We set jump available equal to false, and then we start this coroutine. This coroutine has a yield return new, wait for seconds, 1.2, and after that is completed, then we make jump available true, which allows us to re-enter this conditional. So we can jump more often than every 1.2 seconds there. Finally, for the camera rotate, we do main camera.transform.rotate. This might be confusing because if we just did it like this, it wouldn't work. So the way I have it set up is that I actually have an empty object that I call camera parent. And this is actually what ends up spinning. Because camera parent is at the center of the sphere and camera is a child of it, you'll see that it rotates about an offset of it. Make sure that if you do this, that you set this to pivot mode, because if you set it to center, which is the default, the location of the camera parent won't show up correctly. So I just set the location of the camera parent equal to the player. You'll see that they have the same transform here. And then I move the camera to where I want it to be, so the ball is in full view. And then when I rotate this empty camera parent object in code, you'll see that it does rotate correctly and I get the desired behavior. Okay, I think that is everything. Yes. Okay, so that's how you create a basic controller for a sphere, and you'll get, you have a nice camera movement. You can move, back, forwards, left, right. You have a cooldown for the jump. I think what I'm going to try to do next is make a little bit of a smarter jump detection, because one of the problems with doing it like this and simply having a cooldown is that if you move to a higher surface, let me see if I can demonstrate this. If you move to a higher surface, you'll intuitively expect to be able to jump, but you won't be able to. So here, if I jump right like this, it feels fine. It feels like I'm able to jump as soon as I hit the surface. But if I jump onto a higher surface, then it's actually a while before I can jump. Okay, so that about covers it. Hope you found that to be informative and helpful. If you want to see anything, if you want to see me cover anything else, like I enumerators are a great one. They're very useful. Also, linear interpolation is something that I know a lot of people have trouble with. Just let me know in the comments. And again, thank you. A big shout out to all of my subscribers for getting me to 100 subs. It honestly feels pretty amazing. Oh, and one last thing. Shout out to my friend Tons of Hunt Studios, who does devlogs and inspired me to kind of get back on track. So check him out. I'll probably link his videos, his channel in the video description. All right. Goodbye.